Okay, so the key to this is finding the area of this ring, or this washer here. Once we do that, the rest of it is pretty standard. So to find that area, we start out with a large circle that has a diameter of 40 inches. So that area is going to be pi times what? 20 squared, which is what? 1,256 square inches. Then we have to subtract out that smaller circle, which has a diameter of what? 28. So that'll be pi times 14 squared, which is 615.44. So we subtract that, which gives us 640.56, correct? That's the area of the base. Yes, we did subtract that. So that is our area of our base, and we're going to use that for a couple of things. And you're right, for volume, we're going to take that 640.56 times the 80 inches of length, which is going to give us what? What's it? Something's a little off there. $51,244.8. That is inches cubed. That's our volume. Now I'm going to jump to number 3 here quick. Number 3 down here was to convert that volume to cubic feet. So I've got my 51244.8 cubic inches. Cubic inches on bottom, cubic feet on top. One is 1728, right? Since the 1728 is on bottom, we are dividing by it, gives us 29.66 square feet volume. Cubic feet, yes, thank you. Cubic feet. So now we need to talk about surface area. So we've got that area of the base, the 640.56. Square inches. There is one on the other end that's exactly the same. The question here comes about the lateral area. And what's unique about this problem is that there are actually 2 separate lateral surfaces. There's the outside one and there's the inside one. But they are both just cylindrical surfaces. So let's do the lateral surface, lateral area, on the outer surface. We need to find the circumference or the perimeter of that outer circle. Yep, that's going to be just the circumference, which will be pi times 40, which is 125.6 inches. So that's going to give us a lateral area on that outer surface. 125.6 inches times the 80 inches, which is going to be what, 5,124.48? Does that look right? That's not right. There we go, 10,048 square inches. That's the outside. Now we got to do the lateral area of the inside. So I've got to find the perimeter of the inner, which is the circumference, which is 5 times 28, which is all right, so we got the 87.92. So it'll be that times 87.92 times the 80. $7,033.6 inches squared. So if we add that all up, we have what? 2 carry the 1, 17, 12, 18,362.72 square inches. Is that correct? Okay. Okay. So that's our total surface area. Now we were asked to convert that to square feet. Well, the conversion factor is 144 now, right? So yeah, I'll double check just to, because I'm uptight. No, it's not that. 127.52 is correct. Oops, that'll be square inches or square feet now. Just maybe that little bit of control. I got it that far. I've got to finish it off, darn it. So there's our square feet. Any questions on those? So now you can see this is a problem where none of the standard formulas would find that answer. But by using that simple idea of area of a base times a distance times a height for volume, it's not that bad. And then the area of the bases plus the lateral areas for the surface area, not that bad to do. It's a matter of being able to see those pieces. So there's a very good reason why I define those the way I do. For those of you that are keeping a formula page or something in your book, these are formulas you should have. The volume is the area of a base times the height. Surface area is equal to the area of the base or bases plus the lateral area and lateral area is equal to the perimeter of a base times height. And these are for what we call prisms. Remember, a prism has bases that are polygon. All a polygon means is they have straight sides, all straight sides and curves. And lateral surface can be rectangular. What that means is, like on a cylinder, that lateral surface isn't a rectangle on its own, but you can fold it out into a rectangle. So lateral surface can be folded into a single rectangle. Now, the fact that I'm reviewing that might give you a hint that today we're going to start talking about something that's not a prism. Does everybody have those down? I need another second. 1 second. Okay. I should have you guys like the rodeo when we go there. wrap the legs on the calf, and the calf had to put their hand in the air. Okay, now I can go on. Yep. Yep. So let's say we've got a square base here. I got a little tilted, but it'll work. Just because. There. It's a little bit better. Obviously, we're talking about a pyramid. In fact, we're going to define pyramids a little bit more loosely than what you might be expecting. A pyramid is anything with a regular base on the one end and comes to a point. Now, by regular base, I mean all sides of the base have to be the same. If it has sides to it, and it has to be square. And this one is square. It could be six-sided. As long as all sides are the same, it would be fine. Some of the other math would be a little more complicated, so we're not going to get into that. But like if it were oblong, there'll be an issue, bless you, that we'll come into, and I'll show you what that issue is. For our volume, we're still going to start off with the area of a base. Well, the area of the base here is 18 inches by 18 inches, or 324 square inches. But obviously, this is not a complete box. If we look at a complete box, when we were doing triangles, we just took that rectangle, we cut it in half, and that created our triangle, right? If I cut a box in half, I'm not going to get a pyramid. I'm going to get in red there, you can see it's just a wedge, isn't it? That is not a pyramid. So a pyramid is actually smaller than half of the box. If I cut it this way, cut off this little tip right here, after making that cut, it is now a pyramid. Now the piece that I cut off is just a little pointy tip, so it wasn't half of what was left. So what we have left here is less than half of the box, but it's more than a fourth. To get the exact number, or prove the exact number, I'd have to use calculus. So we know it's between a half and a fourth. What falls between a half and a fourth? A third. So the volume of this is going to be the area of the base times the height divided by 3. Here's the way I remember that. A rectangle is how many dimensions? 2 dimensions. To get from a rectangle to a triangle, we divide by 2. A box or a pyramid are how many dimensions? They're 3-dimensional. So to get from a box to a pyramid, we divide by 3. So that means here this is going to be the 324 inches squared times that height of 12 inches divided by 3, which is going to be 1,296 cubic inches, correct? Surface area. We still have the area of the base. Notice I only wrote it down once. The reason should be obvious, because only one base. Yeah, there's no top to this one. The lateral area needs a little adjustment. In our prisms, the lateral area was the perimeter of the base times the height. That's because in our prisms, if this is my lateral side here, the height of that lateral side is just the height of the box. Well, in a pyramid, that side does not go straight up and down. So the height of the length of that side is not just the height. It's a slope. It goes at a slope. So it's actually going to be more than the 12. But we can find it like this. This is 12 inches here, right? What's this distance? If we assume that point is right over the middle, it's going to be half of the 18, or 9 inches. This here is what we refer to as the slant height. So you need to find the slant. Plus. Yeah. So 12 squared plus 9 squared, which is going to give us 15 inches, is the slant. Next adjustment to our lateral area. We still have to find the perimeter of the base. Perimeter of the base here, 18 inches times 4 is 72 inches, right? We're going to multiply, rather than multiplying by the height, we're going to multiply by that slant. But the shape of those lateral surfaces is no longer rectangles. They are triangles. Divided by 2. Because they're not full rectangles. So for this shape, it's going to be the perimeter of the base, the 72 inches, times the slant of 15 inches, divided by 2, which is what, 540 square inches? Does that look right? I think so. So we add that all up, we get 864 square inches is the total surface area. What do you think? But so, it's always funny because you have some people that are good with the algebra and the numbers, the geometry part they struggle with. Then there's other people that struggled with the variables and the numbers, and the geometry all of a sudden just clicks for them, makes sense. It's rare to find a person that both the algebra and the geometry make sense for. So if it's something where you're finding both of them to be easy, you're a very fortunate person. Okay, hopefully that gave you enough time to catch up there. Let's look at our next example. A cone. You may not have ever heard it called this, but it'll make sense. Cone is just a circular pyramid. It has a regular base, and it comes to a point. So we're going to start out finding the area of the base. That'll be pi times 8 squared, other known as 200.96 inches squared. For volume, you use the pi key. 200.96 inches squared times a height of 15 inches divided by 3. (1,004.8 cubic inches. Does that look right? For my volume? Cool. Yeah, divided by 3. Yeah, you were getting like 1,506 or 7. Yeah. So my surface area, I have the 200.96 square inches is the area of my base. Again, there's only one of them. For my lateral area, I've got to find my two things. One of them is my slant. It's going to be the square root of, you got it. This is 8 here because that's half of the 16. Here's my slant right there. Yes, it is 15 squared plus 8 squared, otherwise known as 17. Still need to find the perimeter of my base, which is a circumference. Pi times 16, otherwise known as 50.24 inches. So then the lateral area is the perimeter of the base, the 50.24, times the slant, the 17 inches, divided by 2. 427.04. Get 628 square inches is our total surface area. Hopefully now you're starting to see why the way I define those volumes and areas is important, because it's just the same for these, just small adjustments. Can you guess what comes next? The sphere. A sphere is unique. A sphere has no bases, it has no lateral area. It is just one continuous solid surface. The only way to get the formulas for volume and surface area of a sphere are from calculus. We don't have time to learn calculus to derive the formulas. So this is one of the few times where I'm going to ask you to just trust me that this is what the formula is. The volume of a sphere is 4/3 times pi times the radius cubed. There are only two defining characteristics of a sphere. One is the location of its center, which when we're finding volume and surface area, we really don't care where it is, we care how big it is. So the second defining characteristic of the sphere is the radius. The size, the volume, the surface area of a sphere are completely defined by that single value, the radius. So if I tell you that that radius is 6 inches, the volume is 4/3 times pi times 6 cubed. To punch that in, you could use the fraction key, but you don't have to. You do 4 divided by 3 times 3.14 times 6 to the power of 3 and get 904.32. That's in inches, so this will be cubic inches because it is a volume. The surface area. Again, it's a calculus thing, so I have to just ask you to trust me. Surface area of a sphere is 4 times pi times radius squared. So the surface area of this one with that radius of 6, 4 times pi times 6 squared, which is going to be 452.16 inches squared. Any questions? What you're saying is you'd be just as well off if I started talking in Italian right now. Swahili? They do in a couple of spots. Oh. 4 times 3.14. Gotcha. So, for your mathematical pleasure, oh, come on now, this stuff is fun, admit
Burning down church is great.
it. So this cylinder here is equivalent to the other cylinder, but it has a cone on top of it. I want you to find the volume of each. Also want you to find surface area, but I'm going to define surface area as exposed surface. So these are both sitting on the ground, which means, and we're looking at the surface that would be painted if you paint them. So that means you don't have to find the bottom. You have to find, basically you're finding all the lateral surfaces. You don't have to find the inside. So I'm going to pause here and give you guys a couple minutes. I realize we're a little short on time, so you probably won't get them all done. But I realize you didn't have enough time to finish it off, but let's take a peek and see what you got. On the left side over here, let's just do the volume first on each to compare. The volume here of the cylinder, we can have the area of the base, which will be pi times 4 squared, which is 50.24 square feet. So that gives us a volume, 50.24 square feet times 10 feet, 502.4 cubic feet. Now I wrote that across the board because that actually applies to both of them. The cylinder is the same size in both of those drawings. On the left side here, to find the volume of that half sphere, it's 4/3 times pi times 4 cubed over 2. Gives us 133.97 cubic feet. Added to the 502.4 cubic feet is 636.37. You got it. That's the volume. On the right side over here, we've got the cone. The volume of that cone is the area of the base, which we already found to be 50.24, times the height of 6, divided by 3, which is 100.48 cubic feet. Add that to the 502.4, we got 602.88. Yeah, that's the 50.24 is the area of the base times the height divided by 3. Yeah. So you can see the half sphere, even though it's 2 feet shorter in height, is still more volume, slightly more volume than that 6-foot cone. Surface area is just going to be lateral area. I want to make sure I have time to give you the packet and give you a little bit of work time, so we'll cut it off. But all the surface area is going to be the lateral area of the cylinder plus half the surface area of a sphere. Here, lateral area of the cylinder plus lateral area of the cone. So it's not a huge stretch. In the packet I am about to give you, we're going to have pages 179 through 194. On those pages, there are gray boxes that contain problems in them. So I will pass this out to you right now, and we'll take a look at it.